Selamat sejahtera. We are from Section 1, Group 2. Now let's proceed to our group presentation.
Hi, my name is Muhammad BAZARUL bin BASERI. Matrix number is CF210014. I will present about project overview. So, this project to design and build a sewage reticulation system and sediment basin for the shop office and shopping complex building in Kuala Johor, Malaysia. Figure 1.1 and Figure 1.2 represent the construction project's advertisement box. Figure 1.3 shows the area of the project. So below is the development advertisement for 1 and 2, located at City, Klejo. So next is, if we can see, figure 1.3 is development area located at City, Klejo. So the two development advertisement in this development area, which are the development of 18 plus 33 units of shop office and 4 units of electrical substation, and the development of a 4-story shopping complex. Extra development are considered, which are 100,000 meter for car park, for car 2 park, and 80-room hotel. These projects is manhole are planned to be installed in sewage transfer lines in this area. The manhole are used for the purpose of access and drainage of civil lines. Sewerage reticulation is the network contributed by pipes and manholes, which is used to collect, transport, and process sewage from buildings and communities. It relates to the system that delivers wastewater from private residents, such as residential houses, commercial areas, and factories. The sewerage reticulation will be designed in accordance with the MSIG. The complete design specification may be found in this report for Chapter 2. So next is for sediment basin. Sediment basin refer to sedimentation pond or settling basin is a structure designed for settling suspended elements from some water runoff or construction site runoff. It is a temporary or permanent basin that enables water to slowly flow in, allowing slate to settle to the bottom before the water flows out. The sediment basin will be developed in according with the MASMA, and it will be a dry sediment basin. The complete design specification may be found in this report, Chapter 3. So that's all from me. Thank you.
Assalamualaikum. My name is YUSOF ISKANDAR bin RAHIM. I will discuss about chapter 2, which is sewerage reticulation system design. We know that population equivalent for MH1 is a commercial area with area 2,574 meters square. So to find the population equivalent, we must look at the table which is have provided by MSIG. So from the table, we know that for the commercial area, we need to multiply by 3 over 100. So the area must be multiplied by 3 over 100 and we'll get 73 PE. So next we go to the dry weather flow. We know that dry weather flow commonly is 225 liter cap per day. So to find the dry weather flow, we need to multiply 73 with 225 and we will get 16,425 liter per day. So after that, we need to convert it to liter per second, which is we get 0.1901 liter per second. After we calculate the dry weather flow, for the next step, we must estimate the peak factor. For the peak factor, they have equation which is 4.7 times PE per 1000 power of negative 0.11. So we insert the value of PE and we get the peak factor is 6.27. After that, we must estimate peak dry weather flow. For the formula for peak dry weather flow, which is peak factor multiplied by dry weather flow that we get for this. So for peak dry weather flow, we get 1.1 liter per second. So for the next one, for this project, we consider that we use ductile iron pipe, which is with diameter 0.285 meter, and we consider that condition of the flow is full pipe flow. From that, we need to calculate the cross-sectional area, wetted perimeter, and hydraulic radius. For the cross-sectional area, we know that full pipe flow formula is pi d squared over 4. After we insert the value of diameter, we will get the answer is 0.064 meter square. For the wetted perimeter, the formula for full pipe flow is pi d, which is we will get 0.895 meter. And for the hydraulic radius, the formula is area over perimeter. After we insert the value of area divided by perimeter, we will get 0.072 meter. To find the velocity of the pipe flow, we use the Manning equation. So from that table, that is the equation of Manning. For this project, we assume MH to MH2, they have slope 1 over 180. So we insert the value of R, slope, and N, which is Manning coefficient, to the equation. We will get 1.075 meter per second. After that, we need to checking the value of velocity. Velocity range must be between 0.8 meter per second to 4.0 meter per second. So from answer that we get, 1.075 meter per second is between 0.8 and 4 meter per second. So we will consider it okay.
Assalamualaikum warahmatullahi wabarakatuh. My name is MOHAMMADDANIAL bin Abdul FATA, and today I'm going to present to you about procedure calculation for the maximum flow rate and the inverted level for our project. So from MSIG, it is stated that minimum velocity values at full bore is 0.8 meter per second, and for the maximum velocity is 4.0 meter per second only. So for the range of velocity design need to be in the 0.8 meter per second until 4.0 meter per second. So this is our formula for the calculating the flow rate, which is Q is equal to AV. So where the Q is the flow rate or discharge, A is stand for cross-sectional area of flow, and the last one V is the velocity of the flow. So this is the procedure of calculation of the flow rate. We take the manhole 1 as a example. So from 0.064 times 1.075, we get 0.068 meter cube per second. And then we convert it into liter per second, we get 68, and then compare it to the peak WDWF value, which is 1.19 liter per second. So as a conclusion, the calculated Q value is higher than peak WF value, so it can be confirmed that the sewerage design is okay. So we move to the next step, which is calculating the lower inverted level. So the information given is the length from manhole 1 is to 2 is 80 meter. The ground level is 24.2 meter. The upper invert level is 23.088 meter, and for the slope is 1 to 100. This information has been given by the surveyor and adjusted by the consultant. So, for the first step is to we need to determine the fall first. So the fall is equal to length of sewer over gradient. We get 0.44 meter. Move to the second step. To determine the average depth, which is average depth is equal to ground level minus upper invert level. We get 1.112 meter. And for final step, we need to determine the lower invert level. So lower invert level is equal to upper invert level minus 4. We get 22.644 meter. That's So for the procedure, we need to repeat for all manhole, which is determine the PE value for each manhole and until the inverted level. So the result is plot to the table as shown in the example. So that's all for me. Thank you.
And now I will continue to present about the chapter 3, dry sediment basin design. First step, we need to determine the sediment basin type. For the dry condition, the soil type is coarse-grained sand, sandy loam, and which is less than 33%, which is less than 0.02 mm. And the category is 1. The hydrological soil group is group A. And then the design consideration, which is settling velocity and the sediment storage. The table sediment basin type and design consideration and the table dry sediment basin sizing criteria is used to design the sediment basin. For the dry sediment basin, the concentrated time is 30 minutes and the surface area is 200 meters square per hectare. The total volume is 240 meter cube per hectare. For the basin dimension, the required area for the project site is the 4.243 hectare and the surface area is 848.6 meters square and the volume is 1018.32 meters cube. And this table is the design criteria of the sediment basin for the sediment control. Next is to design the settling zone. The required settling zone is half of the required volume, which is equals to 509.16 meters cube. The settling zone depth y1 is equals to 0.6 meter, and the minimum depth for the design criteria of the settling zone is 0.6 meter. The settling zone average width W1 equals to 40 meter, and the required settling zone average length L1 equals to 61 meter. The average surface area is equals to 854 meters square. Then we need to check the settling zone dimension. The ratio of the L1 over Y1 is equals to 101.67, which is less than 200. And then the L1 over W1 is equals to 4.36, which will greater than 2. Then we need to determine the sediment storage zone. The required sediment storage zone volume is equals to 509.16 meter cube. For the sediment storage zone, the side slope equals to 2 horizontal and 1 vertical. The W2 equals to 30 meter, L2 equals to 60 meter. The Y2 is equals to 0.8 meter, which must greater than the 0.3 meter. For the V2 is equals to 533 meter cube, which must greater than the volume required, equals to 509.16 meter cube. For the overall basin dimension, at base, the width of the base is equals to 10 meter, and then the length of base is equals to 57 meter. And at depth, the sediment zone Y1 equals to 0.6 meter, the sediment storage zone Y2 equals to 0.8 meter, and then the side slope equals to 2 horizontal and 1 vertical.
For sizing of basin outlet, the spillway for the sediment basin is designed for 10 years ARI, while the proposed spillway dimensions is assumed to be 2 meter in width and 0.6 meter in height. The sill level is set a minimum 300 mm above the basin top water level. To simplify the calculations, the riser pipe flow is assumed to be orifice flow through the top of the pipe only, and the riser pipe head is assumed to be 300 mm. Then Q10 is calculated by using the formula CIA divided by 360, where the average rainfall intensity is calculated by using the equation shown here. This table 3.4 shows the fitting constants dependent on the rain gauge location. Our project is located nearby at JPS Huang Johor. Therefore, by referring to Table 3.4, these derived parameters can be determined. The storm duration D is assumed to be 20 hours and ARI is equal to 10 years. Therefore, the average rainfall intensity is equal to 155.13 mm per hour. By referring to Table 3.5, the runoff coefficient is 0.5. Then the Q10 is calculated and equal to 0.91 meter cube per second. Next, try with one orifice and with a diameter of 0.45 meter at the same level. Allow height of 0.3 meter from central of orifice and C0 value is assumed to be 0.6. Then the Q riser is calculated by using this formula and we get 0.23 meter cube per second. Next, for sizing spillway, the Q required is equal to Q10 minus with Q riser and we get 0.68 meter cube per second. Using the trial dimensions of 2 meter of base width and 0.6 meter of effective head, the discharge coefficient is determined from Table 3.6 as 1.46. Then the emergency spillway discharge is calculated by using the formula shown here and we get 1.356 meter cube per second. Since Q spillway is bigger than Q required, the design is passed. From this Table 3.6, we can determine the spillway discharge coefficient. Next, the total basin depth, including the spillway, is calculated and equal to 2 meter. For traffic efficiency, the sediment yield is estimated at 69.06 ton for the design storm. With the design sediment trapping efficiency of 90%, the total sediment trapped for the design event is 38.84 meter cube, while the sediment storage zone for the basins is equal to 509.16 meter cube. So it would require 13 events of the same magnitude to fill up the sediment storage zone. Assuming the design storm is equivalent to 3 months ARI, the storage zone is likely to be filled up in 3.25 years. Last, for maintenance frequency, the sediment trap is 38.84 meter cube and the volume available for sediment settlement is 1018.32 meter cube. Therefore, the number of storm events until sediment volume is entirely taken up to 26 storm events. Hence, the basin shall be maintained every time after 26 moderate storm events. That's all from our group. Thank you so much.